Chapter 3.6, a summary of curve sketching, day 3. We're going to start today with an old AP question from a couple years ago. We're going to see how they ask you the typical curve sketching question. First off, we'll start, we have a table with the positive, negative, a few values in there when applicable. Let f be a function that is continuous on the interval from 0 to 4. Pay attention here. 0 is included, but 4 is not. Be very important with your graphing. The function is twice differentiable except at x equals 2. We can see it does not exist as a derivative there, nor as concavity. The functions and its derivatives have the properties indicated in the table above, where D and E indicates that the derivatives do not exist. 4, 0, less than x, less than 4, meaning do not count the endpoints. 0 doesn't count, 4 doesn't count. Find all values of x at which f has a relative extremum. Determine whether it's max or min, and justify. To determine extremum, we need to look for sign changes in the first derivative. All right? Here, we go from positive to 0, and then 0 to positive, which means it looks like that. Right? That is not an extremum, because from left to right, it's still getting higher. Right? Here we go from positive to negative. We cross over, does not exist. This is an extremum. Again, this stays negative the whole way, so that's not an extremum either. But we have a relative extremum at x equals 2 because there's a sign change from positive to negative. That means it's a max. So there is a relative max at x equals 2, and the y value is 2, so I'm just going to write it as an ordered pair. There's a relative max at 2, 2. And we need to justify that because our derivative, f prime, changes from positive to negative. Good. And then usually, when they do this, the next question is graph it. Oh, yeah, look at that. The next question is graph it. On the axes provided, sketch the graph of a function that has the characteristics. So first off, what I'd recommend, just plot your points. Plot your points from your critical numbers they provided. So at 0, we have the point -1. At 1, we have the point 0. 2, we have 2. 3, we have 0, and 4 is not on the graph because it's not inclusive. Now, look at the intervals. What's happening in the interval? Well, from 0 to 1, second derivative is negative, first derivative is positive. Second derivative is negative, concave down, first derivative positive is increasing. We have that shape in that interval. And it does end up having a slope of 0, so I should level it off. From 1 to 2, it's positive and positive. Second derivative is positive if concave up. First derivative positive is increasing. Concave up increasing is that shape. There's that interval. From 2 to 3, we're concave down, because the second derivative is negative, and decreasing. Concave down, decreasing, that's the shape. And our last interval, concave up, decreasing, concave up, decreasing, open circle because it's not inclusive. Keep in mind we should have a smooth transition here for the slope. All right? Let's do another one with the table. We got y equals x, square root of 4 minus x. First thing you look at is domain. Look at domain range. Since we're taking the square root, we cannot take the square root of any number less than 0. We're safe as long as x is less than or equal to 4. X gets larger than 4, we can't find a value. All right, so our sign chart is made. A couple things to notice. Right here, first derivative is 0. Sign switches from positive to negative, so we have a relative max right here. Here, second derivative is 0, sign changes. Here we have an inflection point. So when we graph, we want to pay attention to those two things. So we'll graph. We need to see the information, so I'll go to dual page. My domain, x is less than or equal to 4. When x is 4, y is 0. So I'll plot that point, and nothing to the right of that will get plotted. We'll plot my critical numbers. My relative max at 8/3, 3.079. 8/3 is a little bit less than 3. So right there is our relative max. My inflection point at -7/2, 0. -7/2 is -3.5. I'm sorry, -7/2, -9.85. -9.585. So -3.5, -9.5 roughly. That is an inflection point. And then we'll look at the intervals. Between 8/3 and 4, concave down and decreasing. Concave down and decreasing right there. Between -7/2 and 8/3. Again, we're concave down, but here we're increasing. Concave down and increasing. And then after that, between -infinity and -7/2, we're concave up and increasing. Kind of stretching it off the graph, but there's our relative shape. I didn't fit it all on one graph, so you probably want to change your scale so that it does. In conclusion, when sketching these, you want to think of 3 things. 1, domain and range. 2, intercepts and asymptotes. And 3, make a sign chart with focus on increasing, decreasing, concave ups, concave down, all that good stuff.